What's kind of fascinating is that there's actually been these big debates among scientists of like, what's the true smell of human poop? And so they've actually done like all of these experiments and tried to like distill like what's the essence of it.
Hey guys, I'm R Olson and welcome to another episode of Synapse on Science Centric. Synapse is our signature discussion series where we engage in thought-provoking conversations with scientists, journalists, authors, and other thought leaders. Our guest in this episode is Bryn Nelson, a Seattle-based journalist who specializes in scientific, environmental, medical, and travel-related stories. His crappy new book, and I mean that quite literally, is called Flush: The Remarkable Science of an Unlikely Treasure. And it's all about humanity's relationship to our poop and how we can improve upon that relationship. But before we dive in, okay, maybe that's a poor choice of words, a couple of quick reminders. The first thing is you can help keep this series going by liking this episode, subscribing to the channel, and clicking on that little notification bell to be informed when new episodes go live. Number two, if you like what we do here, you can help support us directly through Patreon. We have a number of benefits over there, including early access to new episodes, ad-free episodes, and a monthly patrons-only Q&A with me where you can suggest new show topics or guests. Check out the YouTube description or visit sciencecentric.com/support for more info. Now, with that out of the way, let's get the scoop on poop. So Bryn, welcome to the show. Awesome to have you as a guest. Awesome to have you as I think our second live guest, and we're here at your home in Seattle. So thank you for having us here.
Yeah, thanks so much, Eric. I really appreciate it. Yeah.
Awesome.
Great to be here.
So my first question for you is, why a book about poop? Like, how did you get interested in this topic?
Right.
And then how did the book come about?
Yeah. So my training is in microbiology. So I went to graduate school at the University of Washington here in Seattle. So I've always been interested in microbes. And as a science writer, I did a feature story on fecal transplants for a publication called Mosaic. Uh-huh. And that was back in 2014. And I kind of became obsessed with this topic. The feature story did pretty well. I was hearing from patients and patient advocates that what was holding the therapy back wasn't the know-how, it was the disgust. And so a lot of them were forced to do these DIY treatments at home, basically a fecal enema at home with, things that you would get from the drugstore. And it was shocking to me, but also just fascinating how you go from a folk remedy, essentially, that's laughed at, to something that's in the mainstream of science. And, to the point where poop becomes a commodity, and people are paid money to be donors. And, there was just such a dichotomy there of something that was, disgusting and people were laughing at it. On the other hand, it was so wildly effective. People were basically on their deathbed and were cured. So that kind of got me started. I started then just basically any story that I could find that had to do with reuse and our relationship with our bodies, and eventually it basically snowballed from there, so to speak.
Yeah.
But it actually got me curious about what has value, and that's one of the central themes in the book, is what has value, and the things that we assign value to is often very, very subjective, and nature has different ideas of what really has value.
Right. So it was that paradox between this disgust that people have, but the also usefulness of those things.
Yes.
And maybe, like you're saying, the devaluing of human excrement.
Yeah.
Whereas there's actually a history there, which
Yes.
which we'll get to.
Yeah.
About how we can can use it and how people have used it in the past.
Right.
So I guess my question is that, I mean, even reading your book, I actually, I was like eating something and reading it at the same time, and I was like, okay, I got to stop reading this book because I'm getting kind of grossed out by this. I can't read this and eat at the same time. Like, I got to take a break. So there really is that sort of visceral disgust with poop, right? Where does that come from? Why do we have this visceral reaction?
Right. Yeah, there's a really fascinating evolutionary history to disgust, and it's all, I guess, hypotheses, but basically the idea that we are disgusted, or most disgusted, by things that we feel are most likely to harm us. And so there are different categories of disgust. They tend to be, one is sort of like bodily secretion, so it's disgust of pathogens, pathogen disgust. So things like poop, pee, but also rats, cockroaches. I happen to be horribly disgusted by cockroaches. Other things, slimy things, people who look unwell. Sweaty, greasy. So those are all kind of a category. There's also sexual disgust. So disgust by different types of sexual practices, and disgust by the thought of having sex with someone, right? And then there's also moral disgust. So things like lying, cheating, stealing, things that we find abhorrent. And so there's all kinds of hypotheses about kind of how these have evolved, but generally speaking, there's this kind of a baseline level of disgust that kind of tells us to avoid things that could potentially be dangerous. So some researchers have likened it to like a behavioral immune system, right? So that we avoid things. And that can kind of come across even in shorthand. When I was growing up as a small kid, my parents had these green stickers, and it was called Mr. Yuck. And you would specifically put those on household cleaners or things like that. And it was kind of the grimace, like the face of disgust.
Yeah.
But that was sort of the shorthand for, this is yucky, avoid it.
Yeah.
And that was, literally to protect kids from ingesting poison.
Yeah.
So that was, so that's one example of how it has, perhaps evolved to protect us. Of course, then in excess, it can work the other way and harm us as well.
Right.
So that's another theme of the book.
So, but it's not unfounded that we have this disgust with excrement and don't want to be around it.
No, and in fact, if you ask people around the world what disgusts them most, poop is pretty high on the list everywhere. Right?
Yeah,
so
right.
This is not it's not country specific.
And that's a pretty good clue that it's not just a cultural thing, that it's somewhat hardwired into us to have that level of disgust. And what is it that there's certain smells, for example? What's in there that's cueing us in that this is something that is? Oh gosh,
well there's a fascinating mix of chemicals. And I think surprising. So there are things that are pretty obvious, like putrescine. So putrescine, everyone kind of knows about. Things that smell putrid. There is indole, which is another a chemical, and some people describe it as smelling like mothballs. Some people describe it as smelling like poop. But it actually can be used in small amounts in perfumes and in ice cream and other things. Yeah. So there are all of these chemicals. When you have a lot of it, it may smell one way. When you have just a little bit of it, it actually might be a perfume.
Interesting.
Really jasmine, for example, has a little bit of indole in it. So there are a number of different chemicals. And what's kind of fascinating is that there's actually been these big debates among scientists of like, what's the true smell of human poop? And so they've actually done like all of these experiments and tried to like distill like what's the essence of it, which is kind of funny. But yeah, I mean, that is cueing us. Smell can be a huge trigger for disgust. And so, yeah, I mean, you immediately smell something, that's in the garbage, or, you go by a public toilet that hasn't been cleaned. And I mean, you know instantly that's something to avoid.
Yeah.
So smell is huge. I mean, but it's interesting because we're still learning exactly what is it that we're cueing? Mm-hmm. Is it the mix, of these chemicals, and how is that sort of triggering this emotion, this really intense emotion of disgust?
I wanted to back up just a second. We're talking about disgust with crap. I don't know if you can say shit on YouTube. I guess we'll find out. But what actually is poop?
Good question.
So we have these chemicals coming out of it that stink to us or disgust to us, but what actually is poop?
Yeah. So a good proportion of poop is actually microbes, both living and dead. And there have been various experiments where they've tried to, researchers have tried to come up with, what's the percentage. But typically it's around 40 to 50% of the dry weight of poop is actually microbes. And why that's interesting and useful is that is essentially a sample of your inner microbiome.
Okay.
So, we have a tremendous diversity of microbes living inside of us, primarily bacteria, but also viruses, also archaea, sometimes fungi as well. And so I liken it to kind of like a rainforest in miniature, because you have predators, you have prey. It's really fascinating, and they're all kind of living in this kind of coexistence and in this habitat that we've created for them, and doing some remarkable things. So it's essentially a sample of what's going on inside, and that can tell us a lot of things about diet, as well. Fiber from plants. So you're going to have both soluble and insoluble fiber. And of course, that depends on your diet. So if you eat a diet that's high in fiber, you're going to have more. And as a result, you're going to have bulkier poop.
Right.
If you eat a diet that is very low in fiber, then you'll probably tend to have much smaller weight. And then you have a number of nutrients. So the nutrients that we take in, we use a lot of them, but then we expel a lot of the other ones. So things like phosphorus, things like nitrogen, potassium. And it turns out that these are really great nutrients for plants.
Okay.
And what's really interesting is that it goes beyond the synthetic fertilizers, because when you think of synthetic fertilizers, you think about phosphorus, potassium, nitrogen. Those are usually the three. We are much more of a complete plant food, essentially, right? So feeding the plants, but also conditioning the soil. And so that characteristic has actually been extremely useful when you think about reuse for things like compost, because it's it's plant food, but it's also soil conditioner.
Right.
So those are sort of the main things. The microbes, obviously water, most of it, probably 3/4 is water, but then the microbes, the fiber, the nutrients, and then, some assorted odds and ends, sometimes, pharmaceuticals or chemicals, depending on what we've ingested. Mm.
Now you did a bit of an experiment with this, probably more extreme than most people would go, but I imagine that was in part for this book.
Right.
But you download like 3 apps that can monitor your own stools, and so I guess my question is, what was that a valuable experience? How long did you do it, and is it something that you would recommend that other people do?
The apps, they're quite useful. Basically, it's sort of an observation aid, is how I look at it, right? I mean, you could do it with a notepad. You don't have to have special apps. I mean, these are kind of funny. I mean, one's called Plop, one's called Poo Keeper. There are undoubtedly many more. And I'm actually still doing it. I wanted to do it for at least a year for the book, and then I just sort of got in the habit, so I'm still doing it. You know, I would recommend that maybe people try it for a month, just to get in the habit of kind of observing, you know, their output. And I think the thing is, you know, I think people maybe don't like to admit it to other people, but I think we all sort of secretly are, you know, taking a look anyway, right? So we should just kind of, you know, embrace that, right? Because there's actually a lot of extraordinarily useful things that you can tell about your body just from very, very simple visual cues.
Yeah.
You know, so there's a Bristol Stool scale. It's a 7-point scale. And this is basically giving you cues about transit time through your body. Okay, so, you know, diarrhea, obviously that's obvious. And then you have on the other end constipation, right? So there's the Bristol Stool scale, and then people have kind of added their own flourishes, and, you know, it's rabbit droppings and, you know, corn on the cob and, you know, food items, which is maybe not the best thing to associate this with food, grapes and sausage, but as a scale, it's actually quite useful because you get to learn what your baseline is of like what's normal for you. You know, if things are going well, you're feeling relatively healthy, this is your baseline, so that you know when you deviate from that, you know, for 3-4 days in a row, you know, suddenly you're at one end or the other. That can be an indication that, you know, things aren't going as they should.
Yeah.
Color is also a really interesting and useful one. You know, typically poop is brown. For babies, there can be more colors. It can be green, it can be yellow. There can be a lot of it. It can be explosive.
Yes, I have 2 kids, so I've been through that.
There you go.
You get and as I think you pointed out in the book, it's like you get a lot more interested in you know, reading the feces when you have kids, for sure.
Absolutely. Yeah, kids, dogs.
Pets.
You tend to have these conversations on a daily basis. But it's useful. I mean, and you know, even yellow or green as an adult can tell you that you're maybe not digesting food properly. It's going through your body too quickly.
Yeah.
And the reason for that is normally poop is brown because it's a breakdown in bilirubin, I believe it is, which is, you know, part of the bile that is secreted by your liver.
Right.
I think I'm getting this right. And it starts out green, and then it degrades over time, and it becomes brown. But if there's not a sufficient time for it to degrade, by the time it leaves your body, it'll still be green. And so that can tell you that perhaps you're having you know, some issues with malabsorption. You know, that the transit is too quick.
Yeah. So when it goes through too fast, when you have, say, diarrhea, it's, I mean, obviously a lot more water content. Is that basically what's sort of driving the, you know, differences there?
Well,
like it's going through so fast that the water can't be extracted?
That would be a separate issue. And that is typically your body trying to flush something out as quickly as possible.
Yeah.
Right. And that can be anything from a bacterial infection to overly spicy food.
Yeah.
You know, there are some motility disorders that are associated with diarrhea. Any number of drugs can give you diarrhea. The color is more, it can be, you know, a stool that's fairly well formed, but it may appear differently just because of the degree to which you may have malabsorption issues. Yeah. So it can be slightly similar. I mean, you can have you know, a diarrhea that's appearing more green in color, but typically the color and consistency can mean, you know, different things.
Different things, yeah. So do these apps actually tell you this? They like interpret what visually what's happening?
Yeah, I mean, some of them try to do, and that would be my caution to people who are attempting this or just trying this. I mean, there's a very easy, color scale that you pick, and then kind of the stool scale, and then any notes. Is it especially stinky? If you had corn the previous night,
beets.
What exactly beets? At what point is it appearing?
Yeah.
Because that's fairly obvious. You can take pictures to send them to your doctor. I guess that's probably the main intent, as opposed to sharing them with your friends.
Please don't. Please don't, folks.
Please don't do that. No one wants to see that from your friends. But it is. It's very useful for observing and kind of figuring out what's going on with your own body. I think some of them have tried to interpret that, and I think that I would be a little bit more wary about, because if you're really concerned, you should go to your doctor.
Right.
And not leave it to an app. And in fact, I think some artificial intelligence algorithms have tried to train on color and consistency combinations, and I'm not completely convinced that they're fully accurate. I think, still the best bet is, if you're concerned and there's a picture and you send it to your doctor and you're like, this doesn't look right. Yeah. That would be, the thing that you do first. Yeah. In my opinion.
So leave the AI out of it.
I would. I mean, I just don't think we're there. I just don't think we're there yet with it. And, there's even a toilet that is an AI toilet, and is trying to. It has cameras and it has monitors and sensors, but you're sort of outsourcing your observation, right? Yeah. And so it's basically saying, well, you don't have to do anything differently because we'll do all the work. But then you have no idea of knowing, like, okay, is this accurate? And what are you giving up by just not looking? Yeah. Because it's a pretty easy thing to do.
It's probably true of, that's true of like a lot of medical things. You know your body better than anybody else.
Absolutely.
So like, you know. It.
Yeah. I mean, if you're seeing the exact same thing, generally speaking, 25 days in a row, and then 5 days it's completely off. Something's wrong. Yeah. Yeah. So yeah.
So we're talking about personal health and monitoring personal health by inspecting our crap in the toilet, which actually I got to say, like, after reading your book, I'm actually doing that a lot more than I probably was. I'm like, because I know a lot more about what I'm supposed to be looking at. It's
so you give a crap.
I give a crap about my crap.
Perfect.
But I think what got me interested in your book is this, and I have a genetics background, is this idea of sifting through municipal waste to look for clues about disease and population health. Yep. And that really started and picked up steam because of the COVID pandemic. Yes. Do you actually think that's a useful approach? And
absolutely.
Do you think we're going to see like more of that, or
yes. What I hope so. I hope so. So wastewater epidemiology actually has a long history, and it was used initially for polio back in the 30s, actually, which was a shock to me that it had been around so long. And it was actually a group at Yale University who first, I believe the first two cities they found it in were Detroit and Charleston, South Carolina, during polio outbreaks. And so they had, fairly crude experiments for the time, because then they were, trying to isolate the virus and inject monkeys with it. And so that part was a little gruesome. And thankfully, we have much more refined methods now.
So let me just ask, though, what were they screening? Like, how were they screening for things? Because they didn't have, genomic. PCR DNA sequencing at that time.
No, basically what they were doing is capturing wastewater and seeing if they could replicate the symptoms of polio in lab animals.
Oh, okay.
And they were able to do that and basically prove that the places where they had sampled, at least some of those places, had polio virus that was still active and able to infect. humans and animals. That the refinement of that method now is such that you can do PCR tests that are looking for the presence of DNA or RNA.
Yeah.
And it's become actually an incredibly useful public health tool. In the same way that one of the researchers compared it to when we had the West Nile outbreak that happened in New York, I believe it was in 1999. And one of the very useful environmental indicators is that you started to see crows literally dropping from the sky because the virus was infecting the crows. That actually became a really useful warning to people in the areas where they had dead crows, and they were literally counting dead crows as a way to figure out where you might see outbreaks of the virus. Wastewater epidemiology is you're basically sampling municipal waste, although you can do it even at the level of a building, but typically from a wastewater treatment plant. And you're looking specifically at the presence of the pathogens of concern. So polio, COVID, and monkeypox now have all been detected at the level of wastewater treatment plants, so that you know that it's in a community. What you can do then is you can go up the sewer shed to the level of separate parts of the city and try and figure out where in a city it is. So once you know it's in London or New York, you can then go into some of the utility holes, do your swabbing there, and from your flow pattern kind of where where those sewage is going and what it's drawing from, what part of the city.
Yeah.
And so that's been incredibly effective at giving people a head start. And of course the question is, well, what do you do with that head start?
Right.
Then that's a question of public health.
Yeah.
What kind of resources are you going to bring to bear on that? Is it a priority? But in the book, I do talk about a couple instances at the University of Arizona and at a facility in Yuma, Arizona, a date packing plant, where they used it very effectively during the COVID pandemic to help protect students and workers. So I do think that it's incredibly useful. You've seen a ramp up in the infrastructure. I think with the reemergence of polio in London and New York, for example, and we're probably going to see other viruses popping up, this is something that I really strongly feel we should be building up now that we have this capacity, because this isn't going to be the last pandemic.
Yes, as we were already learning much sooner than I thought we would, but
yeah. So it's a fascinating field of study, and I think that it's proven itself.
Do you think that in a big city like where we're at, New York or Seattle, that you can get a level of specificity to actually do something, though? You're talking about kind of going upstream to get more specific, but how specific do you have to get to? We know it's in this office in this particular building. I don't think we could get to that level of...
Well, it depends on what your goal is. So in some cities, for example, we know that not everyone was at equal risk for COVID, right? So there were some socioeconomic factors that made people more at risk. They had to work. They couldn't quarantine, they couldn't isolate. And if you divide up a city into, 10 parts, 15 parts, or whatever, so that you're getting to the neighborhood level, you can, over time, get a trend of saying, okay, well, we're having a consistent problem in this neighborhood. Let's overlay some of this socioeconomic data on that and figure out, are these people at higher risk? If so, what can we do? Can we, have a vaccine clinic? Can we, make sure that everyone has masks if they need them? Can we do more outreach? Answer questions. So So that's a very useful thing to do. You can do it at the level of a building or a dorm, even if they have a separate kind of sewer outtake pipe, and you can sample right there, and you know that the sewage is coming from the inhabitants of the dorm or workers in a building. And so at this date packing plant in Yuma, they were actually able to detect a silent outbreak where a couple of the workers had COVID. They didn't have symptoms. And they, the sewage, they would make sure that they were testing, after a certain break, after people had used the bathroom on, specific days of the week. And because of that, then they were able to sort of bring in a health department to do testing for the individuals, and so the workers who had an infection were sent home with pay, and asked to isolate for a while. And what was great about it is that they were able to avert a much wider outbreak, because of that. And I think it also then, instilled in the people there that they were trying to protect, the workers. And so what was interesting is by being really transparent and, explaining what they knew, what they didn't know, why they were doing it, what they hoped to learn, when it came time for a vaccination drive, almost every single worker was like, "Yeah, I'll do it."
Yeah.
So
because they knew they were at risk, right?
They knew they were at risk, but they also had the trust of the people who were doing the testing, and they were being told explicitly, "This is why we're doing it. This is what we know. This is what we don't know," and we're happy to answer any questions. So it can actually be a really useful tool to gain the trust of populations so that you have the type of public health follow-up that you need to protect people.
Is there any way that the public can access this data currently about wastewater epidemiology?
Yes,
cool.
a lot of communities actually have dashboards that are publicly available. And it depends on the state and the location. But yeah, in a lot of cases, it's actually folded into some of the other indicators. So you'll have like a hospitalization rate, for example. You'll have the test positivity rate. What are the number of cases? And then what are the relative levels in the wastewater? And that's still kind of an imperfect science because you can't necessarily say based on this level we have X number of cases, right? But what you can say is following the trend over time, it was really low and suddenly we see this spike. And typically what they've learned is that spike can predate when you see an uptick in clinical cases by a week. So it does give you some time if you're doing it right. But yeah, a lot of states and municipalities that are still using it have publicly available dashboards so that you can look and see. There's a company called BioBot that's doing a lot of testing, and they have a dashboard that you can look at. And they've divided up the country, into regions, and so you can say, the West has more right now than the Eastern region.
Do you think that will be expanded into other? I know that people have been looking at just more general things like diet and obesity rates. I think they can know based on microbiome kind of stuff, obesity rates and quality of diet and things like that. I mean, do you think it'll be where you could, I'm just imagining a future where you go to this dashboard and you go, you know what, I know a lot of information about this neighborhood because we know everything that's in their crap.
Is this a good neighborhood to move into?
Well, and
let me look at the wastewater data.
It could be used in that way, which is also, that's an ethical issue, I think. But
no, you're right. I mean, there are indications at a community level based on like antidepressants, based on beta blockers, based on the different types of pharmaceuticals, you can form sort of a profile, and it's imperfect, of course, but there are sort of proxies, of income, based on the type of chemicals that you're seeing, the pharmaceuticals. Communities have used this a lot for monitoring drug use. So opioids, for example, is a huge, that's another pandemic that's going on right now. And so actually BioBot, the company that's doing a lot of testing of wastewater, was initially focusing more on opioids in some communities, and kind of, again, with the idea of trying to direct some of the public health resources to some of the hardest hit areas. But yeah, as you get more information and as you get more of a granular view of what a neighborhood might be like, you do have these ethical issues, like who deserves to know this, like how specific can you be? Can you get to a block level and say, okay, well, let's tell you about the characteristics of the people on this block as opposed to this other block. So I think there is going to be ethical issues that we're going to have to wrestle with and address. And so I think that should be part of the science now, because that's coming. Yeah. There was an effort in Australia where they did something like that, but they were essentially profiling some different communities, and could learn a surprising amount, just based on what they found in the sewer. Yeah. Yeah.
I think I read something that Amazon was developing some kind of monitoring thing for your toilet, and I was like, oh boy, here we go. This is
the Internet of Things. And let me be on the record, like the Internet of Things should not be extending to your toilet. Like it just no. And actually, one of the funny things about this toilet that was being developed, I think it was some engineers from Stanford, and had a little fun with it in the book, maybe at their expense, but I think in the right situation, probably has value in a medical setting. But the problem is that the more technology you add, the more problems you create that then technology has to address. And so one of the really funny things about this toilet is it has a number of cameras that are going to monitor, how much is your output, that'll also be monitoring, I guess, your urine. But they didn't know who would be using the toilet at any given time. And so the solution was to have a camera that would basically be taking a picture of your butthole, your anoderm, right?
Anoderm, yeah. I
your
remember
anoderm.
That phrase, yes. That's a new one. New vocab word for Wordle or whatever.
Here's your word of the day, anoderm. But then they realized that they had to beef up the security because, then you didn't want people hacking into the system and I guess, having pictures of your individual anoderm. I mean, it is kind of like a fingerprint, in a way, so it can identify individuals. But it was just kind of a case of, do we really need to have all of this information automated, or can we just be more observant? Right. And technology can help us. So I'm not anti-technology, and I've the apps that I'm using are technology, but I think there's a limit, to how far we can or should take it until we sort of learn a little bit more about the accuracy and the security. Yeah. And I think right now the Internet of Things just should not be in your toilet.
Yeah, and as we've seen with other social like Facebook and how they use that data and stuff, it's got to be transparent in how that data is being used.
Yeah, absolutely. How's it being used? Who has access to it? And so I mean, there are obviously, there are going to be privacy concerns. There's going to be ethical concerns, in a number of different applications of this. I mean, it doesn't mean that we shouldn't go forward with it, but I think we need to have that in mind.
Okay, so I wanted to switch gears a little bit. We talked about how people are using human waste for epidemiological health reasons.
Yeah.
But how are people using waste to for environmental purposes? What are some cool and interesting things that people are doing instead of just treating it and flushing it into the ocean, which is pretty much right. I mean, that's the main way we get rid of waste still in the West, industrialized West.
Yeah, we still either burn or landfill a surprising amount of waste, and I forget what the last estimate is, but it is I believe like a 30 to 40% is combined is either landfilled or burned, and I think that's a tremendous waste. I mean, you're not necessarily getting rid of the problem, because then you have your landfill. And landfills can leak and, leach both the chemicals, and then you have methane that can escape from landfills, and we know that methane is a potent greenhouse gas.
Right.
So there have been there's been a lot of technology around, well, how do we recapture some of this other potential? And so one of the ways that we can do that is through what's called anaerobic digestion.
Mm-hmm.
And that is basically mimicking what goes on in your gut.
Mm-hmm.
You have anaerobes that are archaea. And archaea, the methanogens are the ones that produce methane gas as part of their metabolism. So it's sort of it's a complicated kind of synergy with other bacteria, but they kind of are using the byproducts of digestion as the different. It's kind of like in the woods, one animal is sort of like picking up the leftovers of something else, another animal. And so our archaea, or methanogens, make methane gas. And so, you can tell that through pyroflatulence, which is basically lighting your farts on fire. And let me go on the record and say that you should not do that. It is dangerous. It works. It's not a myth.
Do you know this from experience?
It is not a myth. I haven't tried this. There was an episode on Mythbusters where they actually proved this.
Oh my gosh.
Yes. So that is a thing, but it is not a safe thing, and you shouldn't try that at home.
Okay. Noted.
But what engineers and scientists have figured out is that in these anaerobic digestion vats, you can kind of recreate on a much bigger scale what's going on, and the waste goes in. You have the regular bacteria as well as these archaea bacteria in your vats, and you can get a substantial amount of biogas that's formed. Mm. And biogas is incredibly useful because you can use it to make electricity. You can use it for steam heat, mm-hmm. And you can also create gas, compressed gas. And in fact, a wastewater treatment plant that I visited in Norway, in Oslo, was using the biogas that they were creating to power 15% of their bus fleet.
Oh, wow.
Municipal buses.
Wow.
As well as some other vehicles. So it's incredibly useful. And a lot of wastewater treatment plants, in fact, have used that production to help cut down on their carbon footprint. Mm-hmm. To sort of make it kind of like a more, a cyclical, production, because processing our waste can be incredibly energy intensive. Mm-hmm. So anything that they can do to kind of cut down on that consumption is going to help quite a bit. And so a lot of wastewater plants have actually become these sort of engines of ingenuity, and kind of how do we reuse this and how do we reuse that? And,
yeah.
So that's one, I think, really exciting example. And obviously there are environmental benefits of that. I guess back to your question of how that benefits the environment, because you're cutting down on greenhouse gases, and you're, avoiding what would be these pollutants mm-hmm. That you're bearing.
So let me just interject. So like the process for processing this waste, this mm-hmm. Human poo, basically, and urine, is you're taking it and you're digesting it further beyond what how it's already come out, semi-digested, and then extracting that gas from that digestion. So does it go into like some kind of big digester, essentially?
It's basically, and there are different types that people use, but they're basically like these big tanks. So part of the wastewater treatment process is you're already using microbes because microbes are really useful at breaking down organic waste. And so the goal is that you want to break it down from a more complex form to a simpler form, and also a form that can harm you, that has pathogens, to a form that's going to be less harmful, right? So microbes are really useful for doing that. But then these specific kinds of microbes, that they've learned, are also really good at basically using the food source, which is kind of other dead microbes that they're feasting on, and organic material. That's the food source for them.
See. Okay.
Yeah.
So it's not necessarily the waste. I mean, it's not the. It's
the processed waste at that point. It's basically just carbon, that they're able to use, and so as part of that, basically feasting on kind of bacterial debris, and bits of organic material, they are then able to produce this gas.
I see.
So you're basically you're taking the starting material, you're converting it to something useful. What you're then left with after this process is kind of the remaining solids. But those can be then reused as compost. And there are different ways to do that as well. But this goes back to the idea that poop has microbes and it has nutrients in it, and it turns out that this is how nature works, right? I mean, for millions and millions of years, a bear poops in the woods, and then green plants grow from that, right? Well, we're no different. We may have different diets, but we've figured out how to do that safely to kill all of the pathogens. And what's pretty remarkable about it is that very rich compost material can then be used for farms, but it can also be used to remediate landscapes. So if you have a fire, for example, you can use the compost to kind of help with your forest regeneration. And the same thing has happened with a number of different even Superfund sites, where they have had coal mines, they have had sand and gravel mines, they have had some contaminated soils, and they have found that biosolids basically give you the substrate to grow plants, but can also help decontaminate the soil.
I see.
So like lead or arsenic contaminated soil, for example, biosolids are really good at both diluting out some of those contaminants, and then also by the nature, kind of the clay-like nature of that, some of those particles will actually stick to the substrate and make it unavailable for plants. So you can actually detoxify some of these contaminated landscapes in place instead of having to kind of scrape off all of the soil and put it in a landfill or something like that. So there is a potential there as well. So
just to kind of simplify it. So you have this stream of municipal waste. One of the things that you can get from it is this biogas. The other one is solids. Is there anything else that we can pull off of that?
Yes. You can also take out phosphorus. So phosphorus is essential for plants. It's one of the essential nutrients for plants. And there's been a lot of concern about what's been called peak phosphorus, but this idea that the phosphorus cycle takes a long time because you basically have these rocks that kind of weather erode. You can get phosphorus from that. Phosphorus is used, it then flows back into waterways, into the ocean, goes back down to the bottom, sinks. So there's a long kind of process over time by which phosphorus is recycled. The problem is that a lot of the accessible stores of phosphorus that we have are being depleted. And so there's a lot of concern over the availability of this. And it turns out that one of the problems with wastewater oftentimes is excess phosphorus. Because we know that if you have too much phosphorus, if you have too much nitrogen, you can actually cause these really catastrophic algal blooms that create dead zones in the water.
I know there's a big one off, like flowing off the Mississippi into the Gulf
in the Gulf of
Mexico.
Mexico. There's a big one there, and a number of other places. So excess phosphorus and nitrogen in places where they shouldn't be can be extremely harmful environmentally. So one of the very clever solutions is, well, instead of having this excess there and trying to figure out other ways to kind of remediate that, why don't we capture the phosphorus, which we need anyway, but in a form that we can reuse? And so one wastewater treatment plant in Oregon, it's called Clean Water Services. It's just to the west of Portland. But they've developed a technique where you basically are able to form these little pellets. They're basically little phosphorus pellets. And it's a very ingenious system. And you can then essentially sell these back to farmers as phosphorus. And one of the, I think, really brilliant things is that this type of phosphorus actually works with the plants. When the plants are hungry, for lack of a better word, and they want more nutrients, they will send out an acid to acidify the soil, and that kind of makes the minerals in the surrounding soil more bioavailable to the plants, right? So they have used this exact same process for these phosphorus pellets. So the pellets are relatively water insoluble, which means that they won't wash out into the streams and cause the same kind of pollution.
I see.
So they, sink down into the soil. When the plants use that, they will send out this acid. I think I want to say citric acid. And then the pellets start to release the phosphorus. So it is entirely dependent on the plant cues that they need more. And so it's working with nature, right? And so that to me was just such an elegant example of taking something that would be kind of disastrous in excess, but something that we also need in other places and are falling short of, and how do you make it much more efficient and use it in a way that the plants want?
Right.
So that's another example of things that we're extracting from sewage.
So to kind of bring it back to where we started with this conversation, we were talking about disgust, right? So I don't think anybody has an issue with biogas, right? Because you just burn it.
Right.
But as you've sort of highlighted in the book, there's still a lot of stigma around these biosolids and the phosphorus.
And I would say, I mean, the phosphorus maybe less so because what you're getting is little pellets there, but I think the disgust is certainly an issue with compost and soil amendments, and it's also an issue with water reclamation. Because another, very important thing that we can get from wastewater is water, is basically reclaiming water. And so the idea, that it's, poo water and, or we're just basically, spraying poop on plants, I mean, there's a mental image there that's not pretty. And so I think there's a lot of work that needs to be done to, convince people that it's safe, that it's well regulated, but then also talk to people about kind of how does nature work? Right, and let's think about the ways that things have been done on the planet for eons. And this really isn't any different than that. So it's the same as water. Like, so water reclamation, for example, the idea that all water is recycled on Earth, is I think an important concept to get across to people. and there have been, other authors who have suggested that, the water that we're drinking now was dinosaur pee. There are other, yes, that's a good image.
Well, and being science people, you can really say like, yeah, that molecule doesn't change, or that element doesn't change, right?
Right.
It's that
Right.
rationally,
Right.
know that. But there's still that visceral thing.
Yes, we can grasp that, mentally, but it's also hard to get over the psychology of it. And so I think one of the things that can be really helpful is that when people see for themselves, how is this made safe? And so for me, I went to the groundwater, Orange County Groundwater Replenishment System, and it is the largest facility of its kind in the world. And I took a tour, and they were pointing out the different methods of purifying the water. And it's right next door to the wastewater treatment plant. So the wastewater treatment plant treats the water to a certain level, then it basically goes next door and then starts another round of treatment. And so you start with microfiltration, there's reverse osmosis, there's ultraviolet radiation and treatment with hydrogen peroxide. And at each step, you can kind of see how the water is becoming increasingly clean. Mm-hmm. And at one point along the tour, there's this sort of triple sink, and it shows what the water looks like after various treatment steps. And the two outer sinks, one is kind of like a pale yellow, and the other one is pretty gross. And the one in the middle is pure water.
Yeah.
And there are cups,
Yeah.
and so there's a little bit of peer pressure there of, okay, we're gonna have a drink of this now, and of course it just tastes like water. And I think one of the important things is that water is so clean that if you were going to use it as drinking water, you actually have to add minerals back, because it's effectively distilled water.
Yeah.
There's nothing in it.
It's just pure H2O.
It's just pure H2O,
Yeah.
and it would start leaching some of your minerals from your body.
Yeah.
So it turns out that is perfect for brewers because it's a blank slate. They can recreate any kind of city water profile they want, such as Munich, and they can create beer with it. Uh-huh. And so beer has actually become a conduit for having these discussions and for getting people kind of past this psychological barrier.
Yeah.
So that's water. Compost, it's the same thing basically as seeing is believing. Mm-hmm. And I think, again, knowing what the treatment steps are, knowing what it's tested for, what are the regulations, I think utilities really have an obligation to be clear and transparent with people about here's what we test for, here's how regularly, here's the test scores that you can find. But I think also just kind of seeing it and smelling it.
Yeah.
For me, that was a big barrier, and I use it in my gardens. I've used it in the vegetable gardens. I've used it in the flower gardens because I wanted to practice what I preach. I wasn't going to make anyone do something that I wouldn't be willing to do myself.
Yeah, absolutely.
But seeing the product and smelling it and basically understanding, well, this is at this point it's essentially dirt. It's a soil amendment, and it happens to be extraordinarily effective for nourishing plants. Mm-hmm. And so one program in Tacoma, just south of here, has created an entire community gardening program around their product, which is called TAGROW, which is short for Tacoma Grow. And it is a recycled biosolid soil amendment, mm-hmm. perfectly safe. And it's incredible because you can see these gardens and see how flourishing the plants are. And so this is distributed free of charge to these gardens. They're not required to use it. They can use typical compost. But when the gardeners who aren't using it see what their neighbors' vegetables look like with it, they said, I want that. I want that. So that's been a really successful program, and it basically is sort of a catalyst for communities coming together to garden. So that's been kind of an extraordinary thing to see and tour. But I think ultimately it just comes down to, seeing is believing, and being able to trust the utility or the government entity that is producing this.
Yeah, right.
And so there, it really is incumbent upon them to be transparent,
Yeah.
and to say, okay, we get it, we understand there's a disgust factor here, let's help you get past it.
Yeah. Cool. Well, we're running short on time, so I think we'll end there.
Okay.
But this has been a fascinating discussion. We barely scratched the surface of flesh. dipped below the surface.
Dipped our hand in.
Dipped our hand in. So, but yes, the book is Flesh, and then this will be available in September.
September 13th.
And
yep, you can pre-order it.
And where else can people find you online?
Okay, so people can find me either on Twitter. I'm Seattle Bryn. Or they can go to my website, which is brynnelson.com. And more than happy to answer any questions that people might have.
Any of their crappy questions.
Any of their crappy questions. Bring them on.
All right. Awesome, Bryn. Thanks so much. Been great talking to you.
Thanks so much, Eric.
All right,
Appreciate
great.
it.